And let's start. When people can join as they want to, and we can post this again later tonight on the YouTube channel. Okay. So last time we did the binomial. No, I am not. We just did the discrete probability. So this week or today, I basically want us to look at the binomial and then also Poisson, so that we can finish that today. And then later in the week, we can start with a normal distribution and look at that, so that at least when we're done with this study unit. Okay, and what I want to show today is more how to use the tables. You will get the table in the exam. If there's, yeah, so again, let's just, so your exam is online, but they will send to you like a pre-pack with tables and those kind of things in, with formulas in as well. Well in advance of the exam, so you can print that beforehand, but they will also give you in the exam the tables as an attachment, but the rest of the exam will be online. Okay, so I think what for me is important is I want to show you how to use the tables for binomial and Poisson, because that just makes the life easier and makes it for you to do it in the exam quicker as well, specifically because you need the time in the exam to do the other things as well. Okay, so when I look at this, I basically, they need to give you the n, and they need to give you pi. So they need to give you those two numbers. So that is a given that they need to give you, otherwise you can't work with it. And what they will also do in the question is, if they want you to work out a probability, they would need to tell you what the x is. So they would need to say, okay, I'm looking at the x of 0 or x of 1 or x of 2 or x of 3 or a combination of x's. So they need to give that to you. So you will always see that they do that. And then the other thing that they can ask you is work out the mean or the variance. And again, that you don't need to remember off by heart. And I'm actually now paging through my notes to see what that normally is. So the mean is n times the pi value. So that is what your mean will always be. Your variance is just a bit different. So let me just add that for you, because probably we'll get that later on. But the variance is basically your mean times 1 minus the pi value. So that be your variance. Okay, so if I ask that to you, so, but basically options 1 to 4, we are going to use the table. And that one we can just normally calculate. So let's do that one first. And they ask us which one is incorrect. So n is 6, pi is 0.2, So that will be 1.2. So your mean will be 1.2. So that will be correct. Okay, so then basically now it is to understand how we can get this from the tables. So when I look at this, the easiest ones are always the ones that are equal. So x equal to 2. So let's first see, we've got n equal to 6. We look at where pi is equal to 0.2. Okay, so we're working with this block. Okay, so then basically where x is 2, so we look at that one. So x equal to 2 is 0.2458. So that is correct. Okay, then we'll look at x is equal to 5. So x equal to 5. 0.0015. Okay, so that one is incorrect because it should be 0.0015. Okay, so that is the incorrect one. But I also want to show you the other two so that when we get that in the exam, you can also do that from the table. So let's take those two out. Take another color. So where x is equal to or smaller than 1. So equal to 1 or smaller. So it's basically looking where x is 1 or 0. So where x is 1 or 0 is those two numbers. So we need to add them to get an answer. So let me just check where is my calculator. So we need to say, if we want to work out the probability of x equal to or smaller than 1, it is the 0.2621 plus the 0.3932, and that is equal to 0.6553. Okay, so that one then would have been correct. So let's look at the other one and let's use another color. So big O equal to, so we look at where 5 is, but it's big O equal to, so it's 5 and 6. So then if we look at 5 and 6, that basically tells us it is 0.0016, which tells me that that one is also correct. So number 2 was the incorrect one. Okay, so that is how I would use the table, and there's a few more of these, so I don't think we need to worry about it now already. We can work through, I think there's 2 or 3 more of them, so that we can get how we use it with the other examples. So let's see what is the next question. I think it is the expected value. So I just want to see if I can copy that. Okay, so when we look at this, here they ask us to work out the expected mean. So we know from the expected mean, it is basically n times pi. Just going to take that out. Don't need that now. So n times pi. Let's just see what is all the new values. Okay, so a certain type of tomato seed germinates 90% of the time. So it's 90% or 0.9. A backyard farmer should probably be planted 25 seeds and not plant. 25 seeds. What is the expected number of seeds that will germinate? So I assume that means that it will grow. So let's quickly see. So I would just say it is 0.90 times the 25. Which will give me 22.5. Which will give me option 5, which is 22.5. I just want to see if there's anything else that they could have asked here. I think the other thing that one can maybe just be aware of is it can be, I don't want to say it will be, just be aware of if they throw in the word not. So if I say not, then we don't work with the 90%, but we work with 10%, because then it is the 100% minus 90%. So just if I throw in the word not here, just remember that that is then saying we want the opposite of that. So instead of 90%, we will look at 10%. So that is just, I think, a caution again to see how they are putting the question and if they want to try to catch you out. So for me, just make sure if the percentage that they give and the question that they ask is the same thing. I just want to take that away. So just make 100% sure that that word and that word is the same so that we can work with a 90%. Okay, so basically we've now worked out, in the previous questions, we worked out some of the probability. Now we've worked out how to work out the mean. So the next one is, okay, so now we're again going to look at probabilities. Okay, so let's quickly see what is here. Okay, let me just quickly. Okay, hi guys. So basically, what we are busy with is the binomial distribution, and then after that the Poisson distribution. So I think what is interesting here, and I've nearly wanted to show you that sometimes the table at the bottom have the 90, the 85, the 80. So if that is at the bottom, it basically means that at the top it is 10%. So if the bottom is 90%, from the top it is 10%. If at the bottom is 0.85, so let's write it in. That is 0.1. So that will be 0.15. And that is 0.2. So you will always see that the top and the bottom will add to 1. So that is pi there at the top, but at the bottom it is also pi. And then the difference in the two is if I get a probability of 10%, I read it down like this. So if I needed to say, what is the probability of x equal to 0? It would have been that value. If my pi was equal to 90 or 0.9, and it then asked me what is the x equal to 0, then I need to read it up from here. So you will see on this side of the table, in the printed ones that you guys will have, there will be a 0, there will be a 1, there will be a 2. So basically then that will be the 0 if it is n equal to 10 with a probability of 0.90 for x equal to 0 will be that one. But again, you guys will see that they will probably not ask that because there isn't a 1. So they would rather ask it in a question like this or with a 0.15. Okay, so let's just go back to what the original question was. Okay, so we're working with 10%, so that is 0.1. Working with that area there. They tell us that a random sample of 10. So I already picked the table that it is 10. So n is equal to 10. And then they say, what is the probability that more than 4? Okay, so more than 4. So what is the probability that x is more than 4? Okay, so more than 4 in the stats basically mean that I'm not including 4, I'm looking at more than 4. So I'm looking at that portion. So that is 0,015 plus 0,001 or 0,001 plus that. So that answer would be equal to 0,0016, which is option 3. If I told us less than 4, then it would have been those 4. If I told us 4 and more, then it would have been these 4. And if I told us 4 and less, it would have been that group of 4. So it's all dependent on basically how they phrase it, what we need to get. Okay, so and you can see if it was less of 4 and less, it would have been, you could have picked that answer. So again, I think if it was only 4, you could have picked that answer. If you included 4, 5, and 6, it was that answer. So it's nearly for each one, there could have been an option for you. So it's very important to understand when they say more than, smaller than, more, equal to, what they are referring to. Okay, let me quickly get a check-in from everyone. Are you fine with that?
I am fine with that.
Okay, great. And so please, in the exam, also just use the table. Don't use the calculator or the formula and those things, because that really is is a bit, when I look at those formulas, I just want to run away from it. So I think the tables is very much easier than the formulas to use. Okay, so let's look at the next one. So the next one, so they tell us again, n is equal to 4. So when I look at n is equal to 4, I know, okay, this is the one that I'm going to work with. Pi is equal to 0.2. Okay, so I'm going to basically work with that one, so I can automatically nearly tell myself, okay, I'm going to work with this group. So when I look at it, I'm only looking within that. So when they ask us, okay, use a binomial distribution and then calculate x smaller than 2. Okay, so let's look. Where's x2? X smaller than 2 is only those two. Okay, weird that it is the same, but that is now, so it is 0.4096. Okay, and it's basically times 2, which will give us the 0.8192. Okay, so it will give us that number. So let's just see if you looked at only 2, you would have set that answer. If you, let me quickly see what else could we get out of here. If you added those two, so small or equal to 2, you would have gotten that answer. So already you can see the difference in, if you've set, let's quickly see, those two together would not, okay, so those two were a bit different how to get that. Would have been interesting to see what the table next to it was, because sometimes what they also do is whatever is the next value can be also that sometimes they reference that, so that you can sometimes make the mistake as you read it that you think it is the value next to it. Okay, but this one was a bit more straightforward. It told you exactly what you need to look for. It told you that you need to look for x smaller than 2, and when it is, you can just read it off the table. Okay, so let's look at another one like that. And yes, a bit. And again, just want to show the difference. So here it was very, very simple. They actually tell you the n, they tell you the pi, they tell you what you are looking for. In this question now, you need to go and look again in the sentence to nearly identify everything. So let's look. According to a report from a Center for Studying Health System Change, 20% of South Africans delay or go without medical care because of concerns about cost. So I would have assumed that is going to be my pi. Suppose 6 individuals, so n is 6, are randomly selected. The probability that more than 4. So what is the probability that more than 4 will delay or go without medical care? So again, that is nearly just want to delay or go without medical care, and that is the same thing that they are also asking us, will delay or go without medical care. So at least we know that that is the pi that we are working with. So pi, we've got there 0.2, n is 6, and I just want to read it again. The probability that more than 4. Okay, more than 4 again is telling us it's 5 or 6. So that is again 0.016, which is option 4. So again, I think it's just important to nearly, and you will see as I go through it, I nearly mark already the things that I think is important and what you will need. So when you get it in that sense of nearly in a sentence or paragraph, that is how I would normally do it, is to say, okay, but let's just find the things that when we look at binomial, we know that we need to find the n, we know we need to find the pi, and we know that we nearly need to find a probability solution. So that is nearly how I would work it out every time when I look at the binomial distributions. Okay, so let's see if we got another one. Okay, so that is basically the binomial. So let's just quickly on this one, let's quickly do the mean, the variance, and the standard deviation. Okay, so for mean, or expected value, we always look, the formula for the binomial is n times pi. So in this instance, it was exactly the same. So it would have been n is 6, pi 0.2. So your mean would be 1.2. Then I think what we always need to be wary of is, what do they ask if I want variance or standard deviation? So if I ask variance, and that is the formula that's in the book as well. So if I ask variance, it is the mean, so it is n times pi times 1 minus pi. Okay, so that would be your n times pi would have been 1.2. Then it would be 1 minus 0.2, which is 0.8. So your variance would have been 1.2 times 0.8. Which is 0.96. If I ask us to work out the standard deviation, we will need to basically square root that. Which is equal to, sure, I hope it's right, 9798. Let me just, check that again. Yes. Okay. So again, be very cognizant of what they ask, because it can be that they're asking you to work out the standard deviation, or it can be that they're asking you to work out the variance. So, and they will give you both as well, or both answers. So I think that is also the one thing that we just need to make sure of, that you just nearly know which one is which, so that if I ask it in the exam, that you will know that. It will be interesting. I haven't looked now at this one if any of those might have been the variance of or standard deviation. It could also be. Okay, so that is binomial distributions. Any questions on the binomial distribution?
No questions on my side.
Okay, cool. So fully understand. Okay, happy with that. Yeah, I think it is nearly the binomial and Poisson. It's one just needs to know how to use the formula or the tables instead of the formulas, because then it is easier to use. Okay, so let's and the other thing, I think what is important is that you will see in most of your questions, they would tell you if it's binomial or Poisson, or they would rather tell you when it's Poisson distribution. When they don't tell you it is Poisson distribution, they would, like in this question, that there will be a time associated with it. So if I don't tell you it is Poisson, there will always be a time. So here they even say it's Poisson, but there is a timeline associated with it. So that is nearly a way of nearly identifying that it is also Poisson. If I don't tell you it, is when they will tell you there is a certain timeline. That timeline can be per second, per minute, per day, per year, per month, anything like that, but it will give you a timeline. And I think that is the important one with a Poisson distribution. Okay, so let's see what they are asking us in this one. So calculate the probability that 3 bank robberies occurred in a day. Okay. 3 bank robberies. Okay, so they only want us to calculate that 3 bank robberies. So not 3 or more, not less than 3, not more than 3, only 3. So in this instance, they want us to calculate what is the probability that x is equal to 3. And then from the table, where the lambda is equal to 1.8, so I already cut and pasted it in here. So it is 1.8. We want where it is 3. So that will be your answer. And then it would have been option 3 as well. But basically with this one, because they didn't tell you more than or less than, they just said 3 bank robberies will happen. So x is equal to 3. It's interesting what they, so that one was when x was equal to 0. That one was when x was equal to 1. That I don't know, and that one I don't know. Maybe there was a combination of things. So again, it basically, just be careful when you read the question that how you answer it. It's strange that there isn't. So maybe if it was, if you added all of that, you probably would have gotten one of the others. So let's quickly, just for interest sake, I just want to see. Okay, not. So, yeah, interesting that and sometimes they would just do to the others as well, but not in this instance. Okay, so this one was really straightforward. They tell you 3 bank robberies, and they tell you what is the mean for a Poisson distribution. Okay, so let's look at the next one. So Poisson distributed was used to model the number of faults in the gearbox of buses. Suppose the faults occur on an average of 2.5. So we've got the 2.5, so that is got the right table. The probability that at least 2 faults. Okay, so now I need to think again. So at least 2. So what does at least 2 means? So what do you guys say? What does at least 2 mean?
Less than 2.
Okay. Okay, see, so all of you are saying 2 and less than 2, 2 and less. Okay.
I say not more than 2, not less than 2.
Say again quickly.
Not more than 2 and not less than 2.
Okay. Okay, so the probability that at least 2 is actually two or more. And that for me is, so at least 2 mistakes. So if you make 3 mistakes, you had at least 2 mistakes. At least 3, at least 4, so at least 2 was covered. If you said at least 1 fault, it's not 2 yet. So it is 2 and more. Okay, so it's a very, very difficult one to nearly explain. I hate these questions where they use the at least and the at most and things like that. And when I look at this one with so many, I would have said, okay, I need to get the probability of 2. So they could have rather said 2 or more than 1, or 2 and more. They could have rather said instead of at least 2. But then again, if I look at that, I don't want to add all of that together. There is just no ways that I want to do that, because then I can easily make a mistake again. So what I would do is I would rather say 1 minus those two. Because if it is 1 minus those two, I would get, my answer would be the sum of those. Because remember, all of that will always equal to 1. So I will explain it again quickly. I just want to get so those two will be 0,2873. And the other thing that I hate is if you look at that question and that answer, it's okay. So let's this one. So if I subtract those two, I get 0,7127. Okay, which is option 1. But look at how easy it was to, if you just swap those two around, and that again can easily happen in the exam because you're working quickly, you see 0,71 and you just pick that one. So again, I think I hate it when there's things like this in, because that just makes you want really, have you done it right? Are you wondering if you are doing it correctly? Or if you just quickly browse through, you can easily pick the wrong one because of the last two numbers. Okay, must I quickly explain the concept of the at least again? So with the at least two faults, it always means that nearly the minimum needs to be at least 2. So minimum of mistakes or faults that can be made is 2, and upwards until how many is possible. So if you only had 5 x's, it would have been 2 till 5. Here we have a lot more, so that is why we add so much more. But basically, at least 2 means minimum of 2 and then more. Okay, anything on that you guys want to? Okay, so let's look at another question like that, and let's see if there's some weird how they talk about it in one of the other questions as well. Okay, so let's look at the next question. So, okay, so this is more the one that I like because there's no misunderstanding in words or anything like that. It is, they give you what you need to look at. So let's look at, so they ask us which one is incorrect. Okay, so first we look at, assume that x is and a variable with that. So I took the table with that so that we can look at the probabilities. The interesting thing here is also when you do the binomial and the Poisson distribution, the thing that I would always work out first before I start looking at the probabilities is to look at my mean and variance. Okay, so the one thing that we know of your Poisson distribution is that the mean and the variance are exactly the same. So if my lambda is 6.0, my variance should be 6.0. So the thing that they have, so the 2.25 of 2.45 is actually the standard deviation, because that would have been the square root of lambda would have given you that. Okay, but this one is then the one that is incorrect. But I want to show you how to get to the other four probabilities as well. Okay, so again, how I would do it in the exam is I would for binomial and for Poisson, if there's in the question the mean or the variance, I would work that out first. And you can sit with my formula page, so you don't even need to remember that. You can actually just sit with a formula page next to you and work that out first. You don't need to remember the formulas or anything like that. So I would work out the variance and the standard deviation and the mean for those two first. So that one was the incorrect one, but let's quickly check how to get to the other one. So when it is equal, it is very simple. It is exactly that number. So when it is equal, it is what is referenced in the table. So we know that is correct. So let's get another color. Smaller than 3. So it does not include 3. So it is from there till there. So let's quickly, smaller than 3 means 2, 1, and 0. So that would have been 0.0446 plus 0.149 plus 0.0025, which would have given us 0.062. Okay, so that is correct. So that is those three numbers. Okay, so let's get another color in here. Okay, so bigger than 5. So bigger than 5 excludes 5 because it's not bigger or equal to 5. It's only bigger than 5. So it is basically from there up until here. So all of these numbers. So sure, that would have been a lot for me to again calculate. So what I would have done, so what I would have done is probably would have said, I would have added those ones and said 1 minus those. It's a bit less to add, so let's do it that way. So if I say 1 minus the sum of these ones, I'm supposed to get to that answer. So it is 0.0025 plus 0.0149 plus 0.0446 plus 0.0892, sure, plus 0.1339 plus 0.1606, which gives me 0.4457. Okay, and that would have given me then 0.5543. So it does give me that. Yeah, so this one was quite a long one. It doesn't really matter which way you go. you needed to add a lot of probabilities to get that one. Okay, so to add 5 or to add, so I'd rather add the 5 and subtract it from 1. But again, luckily we would have gotten that one already as the one that was wrong. Okay, so the last one. So let's check. So smaller than 5. So it doesn't include 5. So it's 4, 3, and then bigger than 2. So it doesn't include 2. So it's only those two that we need to add. So it's 0.892 plus 0.1339, which is 0.2231. Why do we get that? So there's another mistake. Just okay, so there was definitely a mistake in this one. Even if I add that, it doesn't get to it. Even if I add that, it is still. So let's just add the 0.0149. Okay, so that one is nearly should be bigger than 0. Okay, so this one is actually also wrong. Okay, so again, if this happens in the exam, they would give you the marks in any case. So or they give you the marks or they drop the question. So you will not be penalized in the exam if there was 2 mistakes and you picked one of the mistakes. In the exam, what will happen is the question, or everyone will get it right, or they drop the question out of the exam, and instead of out of 25 questions, it will count out of 24 questions. Okay, because that is definitely a mistake. Okay, so are you guys happy with how this was calculated and the ways of doing it?
Yes, I'm happy.
Okay, awesome. Okay, so let's look at the last one, and I specifically have chosen this one because I don't like these kind of questions. For me, this you see what you need to do. Here now you need to be very careful how you read things, and yes, English is not my first language, so sometimes I don't like how they put things. So let's see if we can, especially if you see those words, at least most of, I hate it when they do that. So let's see if we can get this sorted out. So a cashier at Custer's cafeteria can total an average of 1.2 trays per minute. Okay, so they don't tell us it's Poisson, but because it is per timeline nearly, we know it is a Poisson distribution. I think that is the first thing that I want to show. So if it is Poisson, we know lambda is equal to that. So that is the mean. And that is also your variance. So I just want to write those things down when we get maybe anything like that in the question. So then it is already sorted. So we will look at that portion. Okay, so which statement is incorrect? The problem follows a Poisson distribution. Okay, so we know that is right because we have identified it up front. The variance of this problem is 1.2 trays per minute. So we know that is variance, so that is also correct. The probability that the cashier will total exactly 0. Okay, so x is exactly 0. So let's look at exactly 0 if that is the same. So exactly 0 is where it is just 0, so that is right. Okay, so it is exactly 0, so no problem with that. The probability that the cashier would total at least 4. Yeah, so at least 4 means 4 or more. Okay, so it's basically that group. So now the question is, do you add all of those or do you say 1 minus that? It doesn't really matter. There's 1, 2, 3, 4, 3, 4. So I would just add those few together. So it is 0.0260 plus 0.0062 plus 0.0012 plus 0.0002, which is equal to 0.0336. So did I now make a mistake? Okay, so that for me is not correct. So let's just quickly look at this one. So let's, the probability that the cashier would total at most 3. Okay, so at most 3 means 3 or less. So that will also be, that then should be 1 minus the other one. This is quite interesting. So let's quickly add those ones. Because somewhere here is now something that is not right. Okay, this is quite, okay, so somewhere here in the table there is a mistake. So again, please, when you get something like this in the exam, also take a picture. So if I say I add all of those blue ones together, it is 0.9662. So if I worked this out again and I said 1 minus 0.9662, then I would have gotten the the 0.0338. So in here, or that one is wrong, or that one is wrong. So from the table that I have copied this, there was a mistake in that. I just want to see in one of the other tables that I have. So the table that they provided with your study guide, I took it from there. So quite interesting. So in adding these ones, you actually get 0,0336, which I then would have said it's also wrong for this. But if you say 1 minus that, which then it gets you that one. Hoi. Okay, so that one is definitely wrong. This one is debatable in terms of which way you are working it out. I must actually check in the study guide as well. So I got that from your guide that has all the assignments in and those kind of things. There's those tables at the back. I'm wondering from the... I just quickly want to check on your study guide what was the table there. Because again, one wants to make sure that these things are right so that when you get it in the exam, then it must not be any confusion in how to get to it. So let me just check the study guide and I'm just going to copy it next to this table in and see what exactly the same. So interesting. Okay, so if I used the shortcut, because that would have been for me the easiest to add those 4 numbers, I would have gotten a different answer here. If I used those numbers, I would have gotten this answer. Okay, I will just mark this as something that they need to check in the tables what is wrong there, and maybe they printed it wrong. Okay, so that is basically the Poisson distribution, and I think we now looked at where mistakes can creep into the exam as well. But please, when in the exam, if you feel there's a question that you feel is wrong, take a picture of it, send it to me, not to the group, and then I can always, because during the exam the tutors are in contact with the lecturer as well. So I think that one can, during the exam, sort it out if needed. Like last semester, we were in contact with the lecturers so that when there was extra time given, I could communicate to the students as well that there is extra time, because there was some login problems last semester at the beginning. And then just for everybody that is maybe watching this and wants to be on the WhatsApp group, just send me a WhatsApp on 083-790-8387. We will upload this tonight again, and then we will start with basically study unit 6 on Thursday. So what I will again schedule it for an hour to an hour and a half, and let's see how far we get with study unit 6. But I think it's important that for study unit 6 that we get the normal distribution sorted out, because for confidence intervals, for hypothesis, you will need that in any case. So I'll rather spend a bit more time the next session on study unit 6, and we'll finish that on Thursday. Okay, questions from your side? Is it making a bit more sense? Was it okay before we started the session already? Is it helping?
Yes, it's really helping a lot. We are
Okay.
learning a lot.
Okay, awesome. Okay, cool. So we will just continue with this. After all the study units, we'll do 1 or 2 exam preps as well. So we'll get through all the study units, and we will do some exam prep as well. So just I'll also let you know on the group. I've nearly created my schedule on my side, but I will send you through the calendars as we go along. But I think I've scheduled another 5 sessions before you write exams, so we'll get through everything before then. Okay. Have a good evening, and then I'll see you on Thursday again.
Thank you very much.
Okay, great stuff, guys.
Sorry, Jen.
Yes.
Before you left,